Okay, hello and welcome to a practice example. Now, I just wrote this stuff down and I didn't think a whole lot about it because, as you know, I usually like to try to solve these along with you. I don't like to know where I'm going, because we did that in the chapter. We knew what the answers were. We were trying to solve backwards to get there. But now we're going to be going into unknown territory. So see if you can solve this. There are two important questions here. What is the standard error of the mean using this info? And what is the likelihood that candidate A can win over 50% or more when we count all the votes? So we have 6 samples here. Yeah, 6 samples, and each of them has 100 people in it. And so we called them up and we said, are you going to vote for candidate A or candidate B? In the first sample, we got 50% of people said, they would vote for candidate A. In the second sample, we said it was 40% of people said they would. 45 in the fourth sample, 48, 52, and 44. Alright, so go ahead and pause this video and see if you can come up with those two numbers, and we will work it out together in just a moment. So go ahead and try that. Alright, so I'm going to trust that you actually did pause it and you worked it out on your own, because I know that y'all are hard workers and that y'all wouldn't lie, y'all wouldn't lie to me and not pause it, right? So how do we do this? So the first part is the easy part. So what is the standard error of the mean? I gave you the population standard deviation, which is 6 here. So how do we get the standard deviation? Remember that we're going to do, to get this, actually hold on, let me change, can I change my, yeah, I'm going to change the color of my ink. Got to make it blue. Alright, so here we go. So we're going to have something kind of like this. So the standard error of the mean is going to be equal to the population standard deviation divided by the square root of n. Okay, cool. So if we plug in our values here, that's going to give us 6 divided by the square root of 6. I didn't even think about that. So that's going to give us 6 divided by the square root of 6, which is 2.45, which is going to be equal to 6 divided by 2.45 is also 2.45. Weird. So weird. Alright, okay, so cool. We got that. Now, what is the next thing that we need to do? Alright, so we solved this. Perfect. So we would basically say that this is our margin of error. Our margin of error is going to be 2.45. But 2.45 of what? What we would want to do is, now we want to essentially find the mean of the samples. So we're going to find the mean of the samples. How do we do that? The same way we always do. We're going to add all these together, then divide by 6, which is the total number of samples. It's going to be 50 plus 40 plus 45 plus 48 plus 52 plus 44. And that gives me, when I add all this together, it's going to give me 279, and I'm going to divide that by n, which is 6, and so that's going to give me 279 divided by 6 is 46.5. Ooh, that does not look good for candidate A. That means that we sampled 600 people, basically, and that on average 46.5% said they're going to vote for candidate A, which is not looking so good, but we need to factor in our standard error here. That can help us find the appropriate estimates here. So what we do next is we plug that into our z-scores. So we got our z, and remember that the formula here is a little bit different because we're working with the sampling distribution now. So it should look something more like this, where we have x bar is going to be subtracted from the mean, oh, this is a little bit tricky though because it's not what you think it's going to be. And then we're going to divide that by the standard error of the mean. Okay, so what goes in these values? This is a little bit tricky. So remember that we're trying to find for 50, and we just found that it seems like the population is 46.5. And if we wanted to, it doesn't matter too much which of these we plug in for this example. It'll matter much more when we start doing t-tests, but for now it's okay to kind of play around and see what works best for us. I'm going to plug in the sample mean as 46.5. and I'm going to subtract from that the hypothetical population mean of 50. And then we're going to divide by the standard error, which is 2.45. And so that's going to give us, what, 3.5 divided by 2.5? Alright, so 46.5 subtracted by 50 is negative 3.5. And that's going to be divided by 2.45. So all of this is going to give me negative 1.43. Cool, okay. So what does that mean? And honestly, again, the signs don't matter too much. What matters is this absolute distance away from the mean. Because remember, this is a z-score. We can think of this as a pure distance away from the mean. So what is the likelihood now that candidate A is going to get 50% or more whenever they have a z-score of 1.43? We're going to pop over to our calculator now. So yeah, let's see what happens. Well, sorry, I already forgot what the value was. 1.43. So 1.43. I'm just going to plug it in here, and let's see what happens. So I plugged that in here, and then now I get all this stuff. And I don't know what any of this stuff means, right? Like, so which of these values should you pay attention to? Just pay attention to the shaded part of the distribution. We want to know if they're going to get 50 or higher whenever they have a mean of, what, 46.5. So we're going to be looking for the right tail of the curve, which is this right here. So it's going to be 0.07635. In other words, what we're saying is that the likelihood that this candidate has to getting 50 or higher is going to be this score right here. So about 7.64%. So not great, right? Candidate A is in trouble. But still, you may be saying, like, but wait a second, I don't understand how you got this value. And if you did, that's okay, because this is really confusing stuff, and that's why it helps to practice, and that's why it always helps to draw out your distribution. It's also a different example than what we did in the chapter, right? Because we used this last time. But if we're looking at what is likely they're going to get this score or above, we can look at this part of the shaded tail, because we're saying that 50 or above is going to be this. So we plugged in our z-score, and that is what it gives us. Another way to think about it is that our candidate has, if we were thinking what is likely they're going to get 50 or lower, then that's going to be everything from this part of the tail and below. So 50 and below, and that's going to give us 92.3%. So, which makes sense, because really all that is just 100 subtracted by that gives you that. Because the area under the curve is 1.0, as we talked about. And I don't know if you heard, I had an appliance make a noise, and it freaked me out. Yeah, so we're going to say that the likelihood there is going to be 0.076. So our answer here, the likelihood of winning 50% or more, 0.076. In other words, that's going to be 7.6%. And that is it. Trying to think if we wanted to do one more example with this, because we've already crunched a bunch of numbers. What if I said, what is the likelihood that your candidate scores below a 40? What's the likelihood they score below a 43? Do I want to do a 43? Yeah, let's do 43 and see what happens. So let's say, so now we're going to say, what's the likelihood of candidate A winning 43 or less? So what is likely they just get a landslide, just get blown out of the water, right? So what is likely they get 43 or less? So the way that we're going to calculate that, instead of 50, we're going to plug in 43 here. So that's going to give us z is going to be equal to 46.5 subtracted by 43 divided by our standard error. And this is going to give me, oh boy, this is going to be kind of interesting. So, so this is going to give me basically the same numbers. And yeah, actually, let's go through another example, because I don't want to do the same numbers, because it's going to be a little confusing. So let's say 42 instead of 43. I'm sorry to change that up on us. but I just wanted, I'm going to give you another look at it. So in this case, that's going to give us, so 46.5 subtracted by 42 is going to give me 4.5 divided by 2.45 is going to be equal to, so 4.5 divided by 2.45 is going to be 1.84. So it's 1.84, huh? So what is the likelihood that we score 42 or less? And remember, 42 is less than what we are expecting candidate A is going to do, so we can expect that it's going to be on the lower tail of the curve, right? It's going to be below the mean. That might be helpful. So I'm going to plug in 148 now, 1.84. When I do that, remember that I am looking for the extremes, right? And so this is a little bit confusing here whenever I'm looking at this because, and again, I always emphasize why you should draw out these curves, because if we know we're looking for the left tail, right? But looking just at this calculator, this is telling me that our candidate has a 96.7% chance of getting 42 or below. That does not seem likely at all, and it's not likely. So what we would need to do is to take this number and actually look at the inverse of it. So we'd want to actually take this and subtract it from 1, and that's going to give us 0.32, 0.0328884, and that is going to be the number we're looking for. So the likelihood that they score, we're drawing this out, so their mean is 46.5. What's the likelihood they get a 42? It's going to be way over here. I'm shading that part in. It's going to be a low value compared to 50, which is a little bit closer, right? And 50 we established that's 7.6%. So what is this small value? That we're going to take this value 0.0328 and turn that into a percentage. Was it 3.2? Yeah, 3.29, because I'm rounding up. So the likelihood they are going to score less than that is going to be 3.29. This is all just to say that it is very important, in my opinion, to draw this stuff out, because if you're finding numbers in the calculator can sometimes confuse you, and it's just nice to be able to know what you're looking for, and drawing that out can help you know what direction you should be looking for these things and what estimates you're likely to find. And that is it. So that was a lot of practice. So, thank you for hanging in there with me. If you have any questions while you're working on this, just let me know, and I'd be very happy to talk with you about this stuff. So it looks like our candidate is in bad shape. They're less than 10% likely to win. But I guess the good news is that they're probably not going to get a landslide butt kicking, right? They're probably not going to do 42 or below. And that's it. That's all I got for you. So thank you so much for tuning in. I will catch you later. Bye-bye.